Now, in this slide, we'll be dealing with the resolution and the unification. Okay, so when you deal with this prolog, three things that you need to learn. The first one is resolution, second one is unification, then the third one will be learning with backtracking. Okay, so here, okay, so what do you mean by resolution? Resolution says that if C1 and C2 are too close, too home close, and C1 matches with one of the items of the body in the C2, then we can replace the term in C2 with the body of C1. That is, if there are two home close, let it be C1 and C2. Okay, so C1 is a home close and C2 is a home close. Okay, and I say that this is just an example. This is a head. Okay, so this is a head, and these are the tail of C1. Okay, and the C2 is another one close. So this is the head, and this is the tail. This is the body of the on close. Okay, so C1 and C2 are two on close. Let it be. Okay, this is just an example, just to make you understand. I'm writing this. Okay, so as resolution says that, in resolution it says that you can see that C2 is a home close, and one of the item in the body of C2, matches with the head of C1. Right? One of the item in the body of C2 matches with the head of C1. Okay, so this home clause says that the resolution says that you can replace the body item, the item in the body with the body of C1. That is, you can just rewrite this as C2 as A, B, and you can replace this H with Y and Z. So it can be Y comma Z. Okay, this is what the solution says. Okay, again I'm saying if C1 is an onco and C2 is an onco, and in C2 one of the item in the body of the oncos matches with the head of C1, then you can replace the item with the body of C1. I hope it is clear. Okay, so that is resolution. Okay, now next one is unification. Unification means if you need to assign values to the variables. Okay, you need to assign values, or you need to give values. Okay, we say it as unification. And unification has two things that you need to be noted. If it is a constant, it unifies only with the C. If it is a constant, it unifies only with the C. Okay, if it is a variable, it will unify with anything. If it is a variable, it will unify with anything. If it is a constant, it unifies with only itself. Okay, now you know what a resolution is, you know what a unification is. With a resolution and unification, we can just solve a problem. Okay, with using the same thing. Okay, same problem, we can solve it. Okay, so we will explain the resolution and unification. We'll take this example. Okay, so this is a first clause. Okay, this is the first clause, and the first clause found clause, and this is a fact. That means there is no right side. This is the second found clause, and this is also a fact. It doesn't have right side. And this is the third one, fourth one, which is also a fact. And you know that this is a found clause. It do have right side, so it is called a root. So this is a root. You can call this as a root, and all others as fact, because fact doesn't have a right side, but root do have a right side. Okay, now let's consider that for this x as j into O, and let set be okay, let set be CS254. Okay, let H be J Indo and set be 254. Okay, so if H is J Indo and set is CS254, then you can see that this will turn to be, that is, classmate set X is J Indo. Okay, so this is J Indo, comma, Y is takes of X, that is J Indo, comma, CS254, which is the set. Set value is CS254, comma, takes Y, comma, set is CS254. Okay, so that is CS254, Y and CS2, because set is CS254. So here also Y is set is CS254. Okay, so this is how it happens when X is J Indo and set is CS254. You know that in resolution you have already solved. You can take this as C1 and this as C2. You can see that this is the head of C1. This is the head of C1. Since it is a fact, it doesn't have a body. Okay, this is a fact. So C1 doesn't have a body. C2, you know that this is the head of C2 and this is the body of C1. I'm sorry, C2. That is the body of C2. Okay, so when you take off resolution, you can see that when the head of C1 matches with the item, one of the item of body of C2, then you can just replace the body of C1. Here the body of C1 is none. Here the body of C1 is none. So you can just replace body of C1 with null. Okay, that is null with the item. So you can just replace this takes with the null. So the C2 will change to classmate J Indo, comma, Y. Okay, you have replaced this term with null. See the body of C1, which is null. Okay, and it will be equal to takes of Y, comma, CS 254. So that is called, and this is called what? Resolution. Okay, so you have applied the rule and you have resolved this classmate J Indo, comma, Y into a smaller one. Okay, now next is unification. The specialty of unification is that you have two terms here. The one is a constant term, which is CS254. CS254 is a constant term, and capital Y is a variable. Okay, the advantage is that for unification, what you can do is you can just you know that in unification, variable can take any value. Variable can take any value, but constant cannot be changed. Okay, but constant cannot be changed. So you can just try to unify using any of the. You can just try to unify using any of the facts. Okay, which has takes of Y, comma, CS254. We have already taken this, so you cannot. Okay, you cannot. You can just check. We can move to the next one. Okay, takes of Y, comma, CS254. You can see that CS254 is there. Here also CS254 is there. Okay, which cannot be changed. So the second argument of takes cannot be changed. So this CS254 which cannot be changed. Y can take any value, right? So here, since CS254 cannot be changed, you cannot use this one because the second argument is art302. and you cannot take this one because the second argument is his201, but you can take this because this and this because it is CS254. The second argument is CS254, and if I take this takes of y, so y can take any change value. Okay, so y can take the value of Ajit Chandra. That means this can be unified, y is unified with the value Ajit Chandra. So this is same as taken of Ajit Chandra, comma CS254. Clear? That is called unification. You just match with the value. Okay, the two rules are the constant cannot take change the value, but the variable can take any value. So this is same as CS Ajit 254. So the y is taking the value Ajit Chandra. So here you can see that it will be changed to classmate Jane Doe, comma Ajit Chandra, and there is taken Ajit Chandra CS254. If you resolve this, Ajit Chandra CS254, it doesn't have a body, so that is none. So this can be replaced. There is no term like this. Okay, so that is two terms. The first one is resolution, the second one is unification. I hope it is clear. Okay, now we'll move to the last topic, that is backtracking. Okay, so what is backtracking? Backtracking means we'll start from the goal. Okay, you will start from the goal and you will just resolve by going to the pre-existing clauses. You will start from the goal and you will move to the try to reach the pre-existing clauses. That is called backtracking. Okay, so let's see here. So you all know that this example. The first one is rainy of Seattle. Second one is rainy of Rochester, cold of Rochester, snowy of X, rainy of X, comma cold of X. And the question is snowy of C. The query is snowy of C. Okay, the query is snowy of C. Okay, so backtracking, how the prolog finds out the correct answer for this? That is the question. Okay, so you know, if I am writing snowy of C, okay, I have written snowy of C. So if I am asking snowy of C, and if my query is snowy of C, it will check for the rules and the facts, and it will see there is only one rule which says about snowy. It says about X. Okay, so this snowy of C is changed as snowy of X because in query it is snowy of X. Clear? What do snowy of X means? Snowy of X means it should be rainy of X and also it should be cold of X. So it has two parts. So snowy of X do have two parts. The first one is rainy of X. The second one is cold of X. Rainy of X and cold of X. Now we'll start to unify and we'll try to find out which all values satisfies both the conditions. Okay. So first it will to check the snowy of X, it will move to rainy of X. It will take to move to rainy of X. For that, it will initially take the first value that is Seattle. For X, it will take the first value that is Seattle. So you will be checking whether rainy of Seattle. So rainy of Seattle. So it will check for the rainy of Seattle. Yeah, there is something called the rainy of Seattle. So it is true. Okay, so it is rainy of Seattle is true. Since rainy of Seattle is true, what happens? It will go and check for cold of X, where X is a Seattle. So it will check whether cold of X. So if it checks in the facts, there is nothing called cold of Seattle. There is nothing called cold of Seattle. So what happens? It will go back to the rainy of X. It will try to take another combination. Since there is rainy of Seattle but no cold of Seattle, it will move back to rainy of X so that it will take another value for X. So the next value for X is Rochester. Next value of x is Rochester. Okay, next value of x is Rochester. Now it will check for Rainy of Rochester. So Rainy of Rochester is true. Rainy of Rochester is true. So what happens? It will again move to cold of x. It will check whether there is cold of x where x is a Rochester. It will check the facts. Now there is a fact called cold of Rochester. So it happens. It's true. So you can see that for snowy of x, both rainy of x is true and cold of x is true for the value of x as Rochester. For x as Rochester, both rainy of Rochester is true and cold of Rochester is true. So what happens? It returns to snowy of x and it will replace x with Rochester. Clear? Then again it will move up. The query is actually snowy of C. Here you know that C is the same as X. So what happens? C will be replaced with Rochester. C will be replaced with Rochester. So snowy of Rochester is true. That means the compiler returns a value and it will return a value which is the resultant of this query, and the resultant value will be Rochester. That is how actually the problem is solved in prolog. And this purpose in this process in which we'll start with the query or start with the solution, then we'll backtrack to the facts, is called backtracking. I hope it is clear. So this is backtracking.